Students, today we'll learn the superconductors, their synthesis and structure. You know that superconductors are special materials used as the magnets, as the high conducting materials in electronic devices, chips, magnetic chips, the transformers, squid type of the materials, spacecrafts, supersonic bullet trains. Why that are acting as superconductor as supermagnets? Because if this is the structure of the superconductor that is having electron paired domains. When they conduct with high conductivity, they have zero resistivity, so they produce higher magnetic field around it. Electromagnetic field is produced from directing from north to south direction, and hence they act as the supermagnets. One of the ceramic superconductor of class A have the example YBa2Cu3O7-X, yttrium, barium, copper, mixed site oxide, oxygen ions, oxide ions are mixed in the crystal. So this crystal acts as the ceramic superconductor with high Tc, means with a high transition temperature. That is the characteristics of superconductor. So this 1, 2, 3 type ceramic superconductor have structure like this. It has the cubic closed packing unit cell. In the unit cell there are 3 1 by 1 cube as represented here. Middle cube consists of yttrium 3 plus. Top bottom cubes consist of barium 2 plus. Copper 2 plus ions are present at some corners, and other corners are occupied with the oxide ions. Some oxide ions are missing from the unit cell of the crystal. So here that is represented with the number 7-X per unit cell. It has a perovskite type of the structure. Perovskite is special CaTiO3 type ore structure. This ore has a special structure, cubic closed packing with special unit cell. Such structure is observed, perovskite structure representing like this mineral observed by this ceramic superconductor. 1, 2, 3 ceramic superconductor. So what are the special methods used for the synthesis of such materials? The old methods, classical methods are there that are not used today. That old methods were based on the precipitation, vapor deposition, CVD type, chemical vapor deposition, physical vapor deposition, precipitations, co-precipitations, sol gel techniques. So that are not used today for the ceramic superconductors, because these are the old classical techniques that can be used only for the bulk materials. So for this 1, 2, 3 type ceramic superconductors, the discharge methods are used. Discharge and deposition method. So special method used for this ceramic superconductor is arc discharge method. So what is done in this method? In crucibles or containers in a chamber, the complexes of the metals are kept. Suppose Y ligand complex, yttrium ligand complex in one container, barium complex another container, and copper ligand complex in third container, kept in the inert environment in a chamber. They are heated with the thermocouples. So here vapors are produced. That vapors are collected through pipes in another reaction chamber. In this reaction chamber, what happens? All the vapors of that complex of the metals in which ions are formed. Yttrium forms 3 plus ion, barium and copper forms 2 plus ions in that chamber. That ions get oxygenated in the inert air environment. Some oxygen inlet is there, oxygen is passed in that pipe, so here they get oxidized, and this total discharge of vapor that is thrown on a support. So here that discharge is done for the vapors with the IR lamp. So IR lamp is used in the last chamber. From that vapors comes, oxides are formed, and that vapors get deposited on a fixed support. Here the formation of this mixed metal oxide like YBa2CO3 takes place. Some oxide get mixed due to the inert environment and discharge, and in this way the ceramic type of the superconductor is formed. So this discharge type, arc discharge, IR discharge type method is used for the synthesis of the superconductors. Hence superconductors are special materials and used as supermagnets in electronic devices and electrical devices. Thank you.